Hi guys, this is your notes for 3.2. This lesson will take a couple of days because we have some hitches in the calendar. So work as far ahead as you want with this section and make sure you ask questions if they come up. We're going to talk about quadratic equations and the zeros and different ways to go about solving them. Okay, first of all, what is a quadratic equation? Well, first of all, you need to know that a quadratic is any, where's my little writer? Sorry. A quadratic equation is any equation that can be written basically with an x squared. So you're looking at things that when you graph them are parabolas. The reason that it says that a cannot equal 0 is because if a was 0, you would just have bx plus c, and that is a line. So the x squared is required. Now that could look like 2x squared plus 3 equals 0. It could look like 2x squared plus 3x plus 4 equals 0. It could look like 2x squared plus 3x equals 0. So B or C could be 0, just not A. This is called standard form. When there's an x squared, an x, and a number, standard form. And standard form, if you remember from your Algebra 2 days, is good for typing in your calculator, and it's good for finding the y-intercepts. Okay, so if it's a function, we can graph it. The last one was an equation where it was equal to 0, but if it's a function where it equals f of x, we are able to graph it. And when you graph it, when we say something is a 0, basically it is a solution. These words are interchangeable. 0, solutions, roots, all of these words we use are the solutions, and also they are the x-intercepts. So this and this would be what we would call a 0 or a root or a solution. Okay, they can have real number zeros or they could have imaginary zeros. So when do you get an imaginary 0? You get an imaginary 0 if you had a parabola right here. Because if the zeros are the x-intercepts and you can't see any x-intercepts, they will be imaginary. You also could have just 1 0 instead of 2. If it is tangent to the x-axis, that is 1 0, but we call it a double root because technically that same 0 comes up 2 times. So we are going to be solving quadratics today, and there are multiple ways to solve it. You never have to solve a quadratic the way the math lab tells you, especially if it says completing the square. Sometimes they tell you to complete the square when it's a bad idea to complete the square. Factoring is the best. If you're good at factoring, your life will be easier. Getting x by itself is also a very easy way to solve a quadratic, but unfortunately, you cannot solve all quadratics that way. They don't always work. The only two methods that always work is completing the square and quadratic formula. Most kids like quadratic formula the most, but completing the square is easy if you are good at it. So let's practice. The first thing is the principle of zero products, and this is what allows us to solve equations using factoring. Basically what it says is this: if you have a number a being multiplied by a number b and it equals 0, then one of those two guys has to be equal to 0. So when you have an equation, a quadratic, in factored form, this is called factored form, that really is saying that this is a number and this is a number and they're being multiplied together and it equals 0. If that's the case, one of those two numbers has to equal 0. So x plus 2 equals 0 or x plus 3 equals 0. And x would be, if you subtract 2 here, -2 or -3. So this principle of zero products allows us to solve equations by factoring. The principle of square roots problem tells you that if x squared is a number, then you can get x by itself by taking the square root. Unfortunately, kids forget that when you take the square root of both sides, it's the plus or minus square root of k. So this allows us to get x by itself. If you have an equation that said 2x squared equals 32, and I told you to solve it, you can try to get x by itself here. You would divide both sides by 2. You would get x squared equals to 16, and you would take the square root of both sides. But you're looking for two answers because of the square. The square root of 16 is 4, but you have to consider the negative 4, so it's plus or minus 4. Let's look at an example here. It says to solve 2x squared minus x equals 3. We can do this by factoring, but let's pretend you don't. Many students get very confused when it says solve because you immediately are like, oh, I want to get x by itself. Well, that's fine, but you can't. It is not possible to get x by itself. There's an x squared and an x. You can't get x squared by itself or x by itself because the other one would still be there. So when you can't get x by itself, you need to get 0 on one side. And that's how you're going to solve these. Get 0 on one side, and you'll do that by subtracting 3. And it's 2x squared minus x minus 3 equals 0. Now, I'm telling you that this factors. I have many students, though, that when they see a number in front, they don't even want to try to factor because they don't think they're good at factoring, and they would do the quadratic formula instead. And that will be fine, but I'm telling you, let's practice factoring a little bit today. So there is a coefficient here. There's two ways you can do it. You can do guess and check. There's only one way that 2x can break down, 2x squared that is, with 2x and x. There's also only one way that 3 can break down, and that is with a 3 and a 1. If I put the 3 here, the 2 is going to be multiplied by the 3, and that's 6, and that's too big. It won't get me close to 1. So I'm going to want to put the 3 here and the 1 here. I need to get to a negative x, so I'll need the negative to go with the 3 because that's a negative 3x and a plus 2x. Okay, that's one way to factor it. Another way to factor it is to do the AC method, and that's to multiply the a times the c, and you get x squared minus x minus 6. When you have x squared minus x minus 6, you'll factor like normal. How can you multiply to get negative 6? 1 and negative 6 or 2 and negative 3. This is what I need. I need an x plus 2 and an x minus 3, but I changed the problem, and you can't just change a problem. How did I change it? I took the 2 and I multiplied it here and I took it away. So you need to put the 2 back. You put it back in both parentheses. Then you look for GCFs. Does 2x plus 2 have anything in common? Yeah, it has a 2 in common. That would leave you with an x plus 1. 2x minus 3 does not have a GCF, so that's 2x minus 3. And then what we do with the GCF is we just throw it away. Either way, you'll get the same factors, x plus 1 and 2x minus 3. Once you know that x plus 1 and 2x minus 3 is the exact same thing as this guy, then we can use that principle we talked about. If this times this equals 0, then one of these two numbers has to be 0. And how will we find that? Well, if x is negative 1, the first factor will be 0. It's pretty easy to tell. It's just the opposite. The second one is trickier. You might need to write it down. 2x minus 3. How can that equal 0? Well, you'd have to add 3, and you get 2x equals 3. You would divide by 2, and you can barely see that, so I'm sorry. And you get x equals 3 over 2. So the answers are x equals 3 over 2 and x equals negative 1. And we solved that by factoring. After I show you quadratic formula, if you would rather do that with quadratic formula, no one's going to stop you. Okay, how do you solve this one? Well, this one I can get x by itself. That's what your instinct will be anyway, get x by itself. And this time I can because there's not an x squared and an x, there's just an x squared. So we will add 10 to both sides. You'll get 2x squared equals 10. You'll divide both sides by 2. X squared is giving you 5. When you square root both sides, the one thing you cannot forget is there are supposed to be two answers. So it'll be plus or minus the square root of 5. And that was the easy way to solve that problem. How do you complete the square? Well, we did the we did the boxes, okay? And if you don't like completing the square, no one's going to make you complete the square. But completing the square works out really nicely if when you have something in ax squared plus bx plus c equals, oh, a little glitchy, equals 0, it works out nicely if b is even. If b is even and a is 1, it's actually a really easy way to solve it. If you're not good at completing the square, then don't do it. Just do quadratic formula. But we are going to practice a little bit with completing the square here. Here is the example. X squared minus 6x minus 10. Now you might try to factor it first because factoring is really easy. But look, 1 and negative 10 and 2 and negative 5, that won't give me negative 6 because this equation does not factor. So this equation is not possible to factor. You also cannot get x by itself because there's an x squared and an x. So your only choices are completing the square in quadratic formula, which we'll talk about in a minute. So here's how we used to do it. You had an x squared box and you wanted to put it in vertex form. So you needed to think, which perfect square is closest to what I have here? Well, if I have a negative 6x, I could put 3 of those over here and 3 of those over here. So this is closest to an x minus 3 square. That's what this would be. But if I had that in the corner, I would have 9 little ones. So x minus 3, actually, that square is an x squared minus 6x plus 9. But I don't have 9. I have negative 10. So what do I need to do? I need to take away the 9 because I don't really have that. And I also am 10 down, so I need to subtract 19. And that is the same thing as this. These two equations are the same. This is the picture. There's supposed to be 9. But I don't have 9, so I have to take away the 9. I have to take away 10 more, and this is the equation in vertex form. Again, if that's hard for you, then don't do it that way. So why this is nice is because, look, I used to have an x squared and an x. Now I just have 1x. So now I can get x by itself. I would just add 19 to both sides, and I get x minus 3 squared equals 19. Square root both sides. Don't forget your plus or minus. We always have to have the plus or minus. That's the plus and minus the square root of 19. And then add 3 to both sides, and you get some weird answers. It's 3 plus or minus the square root of 19. And that is how you get answers sometimes when you solve quadratics. This is an irrational number. One of the numbers is 3 plus the square root of 19, and you can change it to a decimal if you wanted, but we're never going to ask you to do that. And 3 minus the square root of 19. So how else can we solve them? Oh yeah, the quadratic formula. You all know the song. X equals negative b plus or minus square root b squared minus 4ac all over 2a. And kids really like it, and it helps them, and it's easy. Now, I do see a lot of kids make mistakes when they type it in their calculator. So the way Mrs. Bruno always suggests is kids do it like this. Do the negative b in your head. Write the plus or minus. Do the b squared in your head as well. Then write down the minus 4. Do the a times c in your head or with your calculator, then all over 2a, and do that in your calculator. Then simplify. I will always do problems that way, and I make less mistakes. Be careful if you're typing every little thing in your calculator. Keep in mind, this method always works. Sometimes you have to simplify radicals, though, and some of you are not very good at simplifying radicals. So you need to consider completing the square if you're bad at simplifying radicals, or if you're bad at completing the square, consider getting better at simplifying radicals and use quadratic formula. So we're going to go back to that last question over here, and we already know what the answer is, and we are going to do it with quadratic formula this time. So it's already in the right form. So a is 1, b is negative 6, and c is negative 10. Most kids don't need to do that after you do these a couple times. Remember, it's ax squared plus bx plus c. So whatever number is in front of the x squared is the a, whatever's in front of the x is the b, and so on. Now we do the formula. X equals negative b. Do that in your head. That's 6. Plus or minus square root. I always do b squared in my head as well. I'm going to write this down in case you don't remember it because it's been a while. Okay, I like to do b squared in my head because sometimes my calculator is stupid and will tell me it's negative. Because when you type negative 6 squared in your calculator, you're supposed to use parentheses, but sometimes we forget. So b squared is 36. Minus 4, I always write down, and then I do a times c in my header with the calculator. That's a negative 10 all over 2a, which is 2. That's 6 plus or minus. This is 36 plus 40 over 2. That's 6 plus or minus. 36 plus 40 is 76 over 2. That does not look like what I got earlier, and that is because 76 can break down. So we have to find a perfect square that goes into 76. Now, a lot of my kids first like to go ahead and love math. What do I mean by that? Well, you could put 6 over 2 plus or minus the square root of 76 over 2. 6 over 2 is 3 plus or minus. Now let's break down the 76. 1 squared is 1. 2 squared is 4. Well, 4 does go into 76, I think. 76 divided by 4 is 19. That's 4 times 19, all over 2. So that's 3 plus or minus. The square root of 4 is 2, square root of 19 over 2. Those 2's will cancel, and I get 3 plus or minus the square root of 19. So completing the square is a little bit faster if you're good at it. But the quadratic formula also always works. So you kind of need to pick your poison. Now, when do I use quadratic formula? Well, anytime there is a leading coefficient, I like to use quadratic formula because I don't want to mess around and see if it factors. I just want to try to use quadratic formula. So let's get 0 on one side first. Always get 0 on one side. And they want us to know the exact solutions and the approximate ones. Well, remember the formula. So A is 3. Oh, little glitch. B is 2. And C is negative 7. And we're going to plug it into our formula. X equals negative B is negative 2. Plus or minus square root. B squared will be 4. Minus 4. A times C is negative 21. All over 2a, which this time is 6. So that's negative 2 plus or minus. Now I get my calculator. 4 minus 4 times negative 21 gives me 100 over 6. So that's negative 2 plus or minus the square root of 100. I typed it in wrong, didn't I? It is not 100. You guys are probably stopping me. I was surprised because that worked out pretty nicely. 4 minus 4 times negative 21, I put 24 before. That's 88. That seems better. So that's negative 2 plus or minus the square root of 88. Well, that's 4 times 22. Nothing else goes into 22, I don't think. So I think that's what we're going to deal with here. All over 6. So simplify. That's negative 2 over 6 when you love math. Plus or minus. Square root of 4 is 2 square root of 22 over 6. And we'll simplify that as well. So that's negative 1/3 plus or minus. The 2 and the 6 will simplify. And that will leave you with the square root of 22 over 3 because the 2 and the 6 will simplify. Now, that is the exact answer. What are the approximate? Well, you will type in your calculator, negative 1/3 plus the square root of 22 over 3. So negative 1/3 plus the square root of 22 over 3, and I get 1 point, how many? 3 decimals? 1.230. Now I'll take negative 1/3 minus the square root of 22 over 3. So negative 1/3 minus the square root of 22 divided by 3. Negative 1.897. And that's how you do the quadratic formula. Okay, so what is a discriminant? Discriminant has the root that looks like discriminate. And when you discriminate people, you're separating them. When you're discriminating against somebody, and that's what we're going to do here. We are going to separate the solutions. In the quadratic formula, negative b plus or minus square root b squared minus 4ac, the only thing that we need to know to figure out what my graph will look like is this, b squared minus 4ac. Because if it is positive, if b squared minus 4ac is positive, you might like that better than the greater than 0, you're going to get two real number solutions because you're going to get a square root of a number, which is a real thing, and it will touch 2 times. If b squared minus 4ac equals 0, I'm going to get negative b plus 0, negative b minus 0. So I don't get 2 answers at all. I get 1 answer. It will also be real, and it's what we call a double root. If b squared minus 4ac is a negative number, that means I'm going to have a negative number under the square root. That also means that I'm not going to have real numbers. I'm going to have 2 imaginary number solutions. They will be related. They will be complex conjugates. This is called the discriminant. The discriminant is only the part underneath the square root, b squared minus 4ac. I do have some students who do not use the discriminant. They want to graph everything instead. And if the graph looks like this, they know there is 1. If the graph looks like this, they know there are 2 imaginary. And if they see it, they know they're real. But you should practice with the b squared minus 4ac. Okay, next thing is this. These are called, they're equations reducible to quadratic, but we are going to call them poser problems. And poser problems are equations that we can pretend they're quadratic to make it easier to solve. So we're going to pretend they're quadratic. We're going to solve it. And then we're going to fix it. So what do I mean? This is called, the kids call them poser problems and they call them U problems. Because it's U substitution. Okay, so here's what it looks like. When I see this problem, I'm sad. Why am I sad? Because I don't know how to do it. No, Miss Bruno didn't tell me anything about x to the 4th. But there's 3 parts, and it reminds me of the x squareds things. So I really wish this said, because we're going to use u instead, I really wish that it said instead u squared minus 5u plus 4. That's what I wish it said, because we've been learning about that. And that's what you're always going to do. You're going to go to this middle term, and you're going to say, let u equal whatever the variable is there. In this case, it's x squared. And the reason that's going to be fair is because if u is x squared, then u squared is going to be x squared squared, which is x to the 4th, which is this exact same thing. So before you start the problem, the first thing you need to do is say, I want u to be x squared. And then you can write a simpler problem. Well, this is really smart of me because this problem is easy to solve. I'll make my list for 4. 1 and 4 gives me positive 5, but I need negative 5, so I'm going to use negative 1 and negative 4. So my new factors are u minus 1 and u minus 4 equals 0. Well, that's easy. So this equals 0 or this equals 0. And u is going to equal 1 or u is going to equal 4. And that problem was easy now. It wasn't hard. We're not quite done because it really wasn't supposed to be a u, remember? What was the u supposed to be? Well, u was supposed to be x squared. So now we just finish it. Instead of u equals 1, I need to say x squared equals 1. Instead of u equals 4, I need to say x squared equals 4. And now I can solve for x. Square root both sides. Don't forget your plus or minus. And x is the plus or minus the square root of 1, which is 1. Square root both sides here, and x is the plus or minus the square root of 4, which is 2. So we're actually getting 4 answers because there's a 4 here. I get 1, negative 1, 2, and negative 2. So what do? I change it to something I like better. I make a statement telling me that's what I did. I solve it for u, and then I fix it at the end. I put the x squared where I had it for the u instead. Let's try another poser problem. That's the same one we just did. Okay, How about this guy? Ew, it looks horrible, but there's 3 parts, right? So again, they give you a hint. We're just going to make the u equal whatever that variable was in that middle spot. Now we can change the problem to look normal. U squared minus 3u minus 4. That problem's way easier. We can solve it. Make a list for -4. 1 and -4 gives me -3. So I get u plus 1 and u minus 4 equal to 0. Well, that means this times this equals 0. So u equals -1 or u equals 4. On this one, you do have to be careful though, because u doesn't equal -1. Square root of x equals -1. U doesn't equal 4. The square root of x equals 4. So now we have to solve for x. Now, if you square both sides here, you're going to get +1. So you kind of feel like x might equal 1. But think about what we just had there, guys. The square root of x equals -1. Can the square root of any number equal -1? And the answer is no. This one gave us what we call an extraneous solution, an extra solution that doesn't work. If I plug 1 into this equation, it will not work. 1 minus 3 minus 4 does not equal 0. So you have to throw away that answer. If there is a square root, you have to check. Next, u equals 4, square root of x equals 4, square root both sides, or square both sides, and x equals 16. Does that work? Well, let's see. 16 minus 3 times the square root of 16 minus 4, does that equal 0? That's 16 minus 3 times 4 minus 4. That does equal 0. So this one only has one answer. So if there's a square root problem, you're only going to get one answer. And you'll need to know that because that will show up again on your test. Okay, let's try this last one here. It's a poser for sure. It looks horrible. So I'm going to let u equal m to the 1/3. And now I'm going to change it to something I like better. U squared minus 2u minus 8 equals 0. I like that way better. Make your list for -8, 1 and -8, 2 and -4. That's what I need. So I have a u plus 2 and a u minus 4 equal to 0. That means u is -2 or u is 4. But I'm not solving for u, I'm solving for m. So that means m to the 1/3 equals to -2, and m to the 1/3 equals 4. You might not remember, but how do you get m by itself here? You cube both sides. So I'm going to get m equals -2 to the 3rd power is -8. When you cube both sides here, you get 4 to the 3rd power, which is 64. And both of those will work because you don't have to worry about the square roots there. Okay, I think that might be it. Let's see if there's there's a word problem. We're not going to talk about the word problems. We're going to talk about the word problems in class when you do your math lab. Okay, that's it.